Hello all, welcome back to our tutorials. So in this specific tutorial we will learn about flying capacitor voltage converter. um, Before going into the details of the specific circuit, we will just see what is the need of the circuit. So in embedded applications we know that they are powered by voltages like 3.3, 5 volts, 24 volts, 12 volts, 48 volts kind of applications. uh, but there are sometimes where you might need a negative supply in your board. So most of the cases, if you see, one of the major needs could be operating a op amp negative rail. Like we know that op amp has a positive and negative rail, so operating the negative rail of the op amp could be one of the major requirement for this negative voltage. So definitely there is a very less requirement for current. Like most probably the current could be around 2 milliamps, or worst case 3 to 4 milliamps. So very less current is required in these scenarios. So in a board you definitely require a negative voltage sometimes based on your application. And now this is where one of the circuit called flying capacitor voltage converter could be in the need. So we will discuss about other circuits in future terminals. We will discuss in brief about this specific circuitry. Now again, one of the thing we have to see here is nowadays most of the embedded applications use ICs, where you don't need the discrete circuitry. So even for this specific circuitry also, there are ICs available in the market too, which can generate positive to negative. So most of the embedded designers use these circuits, use these ICs because of their space constraints, rather than designing a discrete solution and having trouble of debugging and bringing up that specific circuit. So if you see here, this is the basic structure of this flying capacitor voltage converter. Because there is a capacitor involved here, at this place where it gets charged and discharges to this capacitor. This specific circuitry is called a flying capacitor, and because it converts voltage from positive to negative, it is called a voltage converter. So just to see in the construction of this circuitry, there are two switches here at the input, switch 1 and switch 2. Switch 1 is powered with the positive voltage and switch 2 is connected to the ground, and these two switches output to a polarized capacitor. So and then the output of polarized capacitor is connected to switch 3 and switch 4, which are again connected to positive and negative terminals, and then to the negative terminal of a polarized capacitor you connect the switch 4. So this capacitor is in reverse connection, and these switches are connected using a pulse. So and there is a buffer inverter where if you on these switches, or if you apply specific voltage to this switch, the inverter would give the negated voltage or the reverse voltage of that specific voltage to these switches. So what would be the functionality here is, basically when you apply a voltage here, the switch 1 and switch 2 shall be on. So in this case, the positive voltage that is applied passes through switch 1 and it charges the capacitor here. So once the capacitor is charged, after a specific interval of time, like again you can calculate that. So when you apply a negative pulse here, so that means you have a high here because of the inverter, these two switches shall be on, and this capacitor starts discharging. So the discharge would be in such a way that it flows from positive, and then it goes through this terminal. So now the positive is at a higher terminal, and then there is a negative voltage that is being developed across this capacitor, which is seen as a negative output voltage. So you can see here one of the major disadvantages is that the output current carrying capability would be, or current supplying capability would be very less, because there are only capacitors and storage with the capacitor involved. So most of you guys who have worked with super cap or those kind of applications, or a capacitor charging kind of applications, where there is exponential charging and discharging, would be very much familiar on the current carrying or the supplying capabilities of the capacitor. So to see this circuit in realization, so this could be the circuit. So now if you see here, there is a positive and negative NMOS switches which is connected to a supply of 3.3, and then there is a pulse that is being generated. There is an inverter buffer. Output of the pulse is connected to these switches, and then the output of buffer is connected to the second switch of switches. There is a capacitor here, which gets charged, and there is a capacitor which is connected in reverse polarity. So this is the basic construction if you see the actual circuitry. Now if I try to run this, so I'll just try to probe the voltage here. So you could see here, I am trying to probe the voltage of node C2. So there is a negative voltage that is being generated. So now this we can say ripple on the output voltage, or fluctuations on the output voltage, are mainly due to the on and off conditions, where you can adjust your circuitry and add additional components to have a smooth negative voltage. So the maximum negative voltage we are getting here is 0.9 volt. So again, this circuit requires some tweaking to understand to get the required output voltage. You can use this circuitry and start building up your positive to negative voltage converter. So here you have used LT Spice to just demonstrate how the circuit works. Use your own design methodologies and design knowledge to come up with a good circuit, or build a good circuit around this basic circuit, to have a stable voltage which can give the required sourcing for the load. Thanks for watching. Please comment if you have any questions on this specific video. Thanks for watching.